Hello and welcome. So in today's video, we are going to solve this algebraic equation that involves two square roots walk into an equation. One wants a number and the other wants its negative. Can they add up to 2? Let's test that mystery and see whether the answer hides in the reals or in the complex world. So here it is given that square root of x plus square root of minus x equal to 2. We'll first check for real solutions because square roots behave differently depend on whether x is positive, 0 or negative. And then for curiosity, peek into the complex solutions. So the real principal square root, in fact, square root of x is defined if and only if x is greater than or equal to 0. Similarly, square root of minus x will be defined if and only if minus x is greater than or equal to 0, which implies that x is less than or equal to 0. Both conditions are true simultaneously only when x equal to 0. So the only candidate in the real number solution is x equal to 0. So if we check the solution for x equal to 0, so the resultant is like square root of 0 plus square root of minus 0 is equal to 2. So the left hand side becomes 0 plus 0 and right hand side still is 2. So the resultant of left hand side will be 0 and right hand side is 2, which is never true. That means there is no real solutions exist for the given equation. So if we follow the complex numbers, square roots are multi-valued, but we can use principal square root and solve algebraically. Let a is equal to square root of x and b is equal to square root of minus x. With this manner, we have a square is equal to x and b square is equal to minus x. So, adding these two conditions, we will have a square plus b square is equal to x minus x. So, the resultant will be like a square plus b square equal to 0, which further implies that b square is equal to a square negative. That means the value of b will be plus minus iota a, where iota is square root of minus 1. We also have the original equation, that is a plus b equal to 2. So here we will consider two cases in order to find the values of x for the given equation. So in case first, we have considered that b is equal to iota a. So if we put this value and let's call it equation number 1. So if we put b is equal to iota of a into equation number 1, the resultant will be like a plus iota a is equal to 2. So further it can be written as a times 1 plus iota equal to 2. So the value of a can be given as 2 divided by 1 plus iota. So if we multiply the numerator and denominator by the conjugate of 1 plus iota, the resultant will be like a is equal to twice of 1 minus iota divided by 1 plus iota times 1 minus iota. So it can be written as twice of 1 minus iota divided by, so 1 plus iota times 1 minus iota can be written as 1 minus iota square. And the value of iota square is minus 1. So the resultant will be like twice of 1 minus iota divided by 1 minus minus 1. So the resultant will further be like twice of 1 minus iota divided by 2. And these two quantities will be cancelled out. So the value of a will be 1 minus iota. So, in fact, we have to find the value of x, and we have earlier assumed that a square is equal to x. So here the value of a is 1 minus iota. So x can be written as a square. So it can be 1 minus iota raised to 2. So if we use the identity of a minus b raised to 2 in 1 minus iota raised to 2, so the resultant will be a square, that is 1, plus b square, that is iota square, minus twice of 1 into iota. So it can be further written as 1 and iota square is minus 1. Then we will have minus 2 iota. So these two quantities will be cancelled out and the value of x will be minus 2 iota. So this is the first solution of the given equation, is square root of x plus square root of minus x equal to 2. So further we will consider the case 2, that is, here we will be taking the value of p as minus iota a and put this value into the equation, that is a plus b is equal to 2. So the resultant will be like a minus iota a is equal to 2. So further it can be written as a times 1 minus iota is equal to 2. So the value of a from here can be given as 2 divided by 1 minus iota, and if we multiply by the conjugate of 1 minus iota in numerator and denominator, so it can be written as a is equal to twice of 1 plus iota divided by 1 minus iota and 1 plus iota. So it can be written as twice of 1 plus iota, and denominator will become 2. So these two quantities will be cancelled out and the value of a will finally be 1 plus iota. And further we have assumed that a square is equal to x. So here x can be written as a square. So if we use the value of a, that is 1 plus iota, so x can be written as 1 plus iota raised to 2. So further it can be written as 1 plus iota square plus 2 iota. And iota square is nothing but minus 1. So these two quantities will be cancelled out and the value of x will be 2 iota. So this is the next solution of the given equation. So under the principal square root choices, the two complex solutions are x is equal to 2 iota and x is equal to minus 2 iota. The moral of the solution of this question is, very first we have to check the domain. If the domain fails for the real solutions, then we have to go for the complex numbers. So that's the power of extending your number system. Sometimes the answer is just one imaginary step away. So thank you so much for watching this explanation. If this video helped you, then do like, share and subscribe to the channel for more smart math solutions or tricks like this. Your support motivates me to bring more amazing content for you. See you in the next video, and remember, math is fun when you understand it.